October. Hi ladies, this is Mrs. Blaufuss here. This video is for October 7th. And in this lesson, we're talking about two key terms, adjacent angles and a linear pair of angles. Now, both of these terms you've seen before, but we're just going to do a little bit more practice with identifying adjacent and linear pair of angles. So first, let's define adjacent angles. We don't actually have a formal definition for this yet, but we have just used it in our definition for linear pair. So let's go ahead and define adjacent angles. It is a pair of angles that share both a side and a vertex. So in adjacent angles, both of those two things have to be true. So let's look at these examples. In the first one, angles 1 and angle 2 share a vertex, but here are the sides of angle 2, and here are the sides of angle 1. Okay, so we can see that they don't share a side, although they do share a vertex. So in this first example, no, because they do not share a side. Let's look at this second example. First, let's go and look at the vertices of the two angles. Here's the vertex of angle 2, and here's the vertex of angle 1. Although this is a shared side of both of the angles, the two angles do not share a vertex. So here again, no, because they don't share a vertex. Okay, let's look at the next example. Here's a vertex for both of the angles, and here is a side of angle 1. It's also a side of angle 2. So in this example, yes. The two angles share a side and a vertex. In the next example, these two angles don't share a side or a vertex, so no. In the fifth example, here's the vertex of angle 1, here's the vertex of angle 2, and although they do share this side, the two angles do not share a vertex. And then the last example, our sixth one, here's a vertex, and here's a side of angle 1 and a side of angle 2. So in this last example, yes. Okay, they are adjacent angles because they share a side and they share a vertex. Let's look at our definition of a linear pair of angles. So a linear pair of angles, we said, were a pair of angles that share a side and a vertex and add up to 180. So let's look at this definition. A pair of angles that share a side and a vertex. This is the definition we just gave for adjacent angles. And the second part of this definition says that they add up to 180. And this is the definition we have for supplementary angles. So we can say that a linear pair of angles is a pair of adjacent angles that are supplementary. Okay, so if you look at this diagram on the left, we know that these angles are supplementary because they form a straight line, and a line measures 180 degrees. And we know that they're adjacent angles because they share this vertex and they share this side. So angle 1 and angle 2 are a pair of supplementary angles. Okay, now if we look at the second part of this, it says name an angle that forms a linear pair with angle 1. Okay, here is angle 1. Okay, angle 1 we could also say is angle ACM. So we want to name the angle that forms a linear pair with ACM, and that means we want it to form a straight line. So the angle that we have is angle ACE. Okay, the second one asks, do angle TCH. So I'm just going to erase what I have so that we can identify that angle. Okay, it says do angles TCH, and angle TCM form a linear pair. And if you look at this, you can see that they do not form a straight line. So no, because the two angles are not supplementary. Okay, and then let's look at the last question. It says name the angle that forms a linear pair with MCH. So here's angle MCH. We want a linear pair, so we want this straight line right here. So that's angle 4, or you could also say angle HCE. Say angle HCE, or you could also call it angle ECH. It's all the same angle. And then let's look at this last example. It says in the figure below, angle KAW. So again, I'm going to outline those angles. KAW and angle LAK are in the ratio 3 to 1. So if you remember the ratios from algebra, a ratio 3 to 1 means, in this context, that for every 3 degrees of angle WAK, there is 1 degree of KAL, or LAK. So that means that angle WAK is 3 times as big as angle LAK. So to set this equation up, I know that the two together, WAL, is the sum of those two angles per our angle addition postulate. So I know that angle WAL is 116 degrees. So first I'm going to write this using the angle addition postulate. So I know that angle KAW plus angle LAK equals angle WAL. Really, I should say measure of these angles. So the measure of angle KAW plus the measure of angle LAK equals the measure of angle WAL. Now, I don't know what KAW is, and I don't know what LAK is, but I do know that this is 3 times the measure of angle LAK. Okay, because it's in the ratio of 3 to 1. So I'm going to say the measure of angle LAK, let's just say the measure of angle LAK equals x, okay, some unknown variable. And therefore, I can say that this is 3x, and LAK is just x. So now I can go ahead and substitute the variables and values that I have. Okay, so KAW right here is 3x. LAK is just x, and I know together that that equals 116 degrees. Or 4x equals 116 degrees. by combining my like terms. And then I can divide 116 by 4, and I get x equals 29. Okay, that's a weird 9 because of my font. Let's just change that so it's actually legible. Okay, so x equals 29. That means that the measure of angle LAK equals 29 degrees. And the measure of angle KAW equals 3 times 29 degrees, which is 87. And I'm going to use my degree signs. Oh, there we go, degrees, degrees. And together, they should add up to 116. So if you double check, they do. So remember to use your angle addition postulate, and I would always just rewrite some equation just using general angles that are given, and then go ahead and substitute values for each of those. So please jot down any questions you have, and we can go over them in class next time I see you. Thank you.